Introduction to logic circuit testing. Testing plays a crucial role in a digital circuit design, ensuring reliability and functionality. Logic circuit testing and fault detection. The presentation explores the fundamental concepts and techniques of logic circuit testing, focusing on fault models, testability, enhancement, and advanced testing method. The cost of costing. Testing represents a significant portion of manufacturing costs, ranging from 30% to 70%. Example 1. Verifying the functionality of CPU. Example 2. Safety critical automotive system. The vector generation. The test vector generation aims to create input vectors that detect a high percentage of faults. For example, the algorithm, that path sensitive technique to propagate fault effects. PODEM, path oriented decision making, explores possible solution. FAN, facilities automatic test generation efficiency. Understanding stuck at faults. A wire connected to ground represents a stuck at 0 fault, while a wire connected to VCC is a stuck at 1 fault. Stuck at 0. A wire permanently connected to ground, stuck at 1. A wire permanently connected to VCC. Observability and controllability. Controllability refers to the ability to set specific value at a node, while observability is the ability to observe the value of node at an output. Scan chains for enhanced testability. Scan chains improve controllability and observability by providing a detected path for data access, designed for testability and fault coverage. Advanced fault simulation techniques. Deductive and concurrent fault simulation techniques offer efficiency and accuracy for large circuit. Deductive fault simulation and it deduce fault effects from good circuit simulation, and concurrent fault simulation, simulating good and faulty circuit concurrently. Fault simulation techniques. Fault simulation techniques are used to analyze the behavior of circuits under various fault conditions. Examples: first, serial fault simulation, simulating each fault individually, and parallel fault simulation, simulating multiple faults simultaneously. Types of faults in logic circuits. Logic circuit can experience various faults, with stuck at being at most common. Stuck at fault, a node permanently stuck at logic 0 or 1. Bridging fault, and uh, unintended connection between two nodes. And third, delay fault, a signal delay that uh, affects circuit operation. Fault models representing defects. For example, stuck at faults. A stuck at faults, also called SAF, occurs when a node in a circuit is permanently fixed to specific value, stuck at 0 or stuck at 1. Uh, Another example is transition faults. These faults affect the signal's transition time, causing it to rise or fall slower than intended. Bridging faults. Bridging faults represent a short circuit between two signal lines, causing unintended signal flow. Stuck at faults, a key model. Stuck at faults is a key model which represents various stuck at models, like stuck at 0. In stuck at 0, output of gate is always 0 regardless of input values, and in stuck at 1, the output of gate is always 1 regardless of any input values. For example, AND gate. To detect an output stuck at 0 volt in a 2-input AND gate, the input vector is 1 1 required. Designed for testability. Scan chain insertion. Scan chains allow sequential access to internal nodes for testing and controllability. Boundary scan. Testing of interconnection between chips and enable board level testing. Test generator is made. Then output response analyzer analyzes the circuit's response, and then test controller manages the overall test process. Advantages of BIST. Reduced test cost as external test equipment is not needed. At speed testing, patterns are generated and analyzed at the circuit's operating speed, and the field testing capabilities allow various diagnostics. There's advanced fault models and techniques. Delay fault testing detects timing related faults, ensuring correct signal propagation with the circuit. And IDDQ testing, monitoring quiescent current to detect defects as faulty transistor can draw unintended current. Memory testing. Uh, in this, first there will be match test. Specialized match test are specialized algorithm for testing memory cells, ensuring proper write and read operation. Then pattern sensitivity testing examines the memory response to specific pattern to detect potential defects. Emerging trends in testing. AI-driven test generation utilizes machine learning to optimize test vector generation, achieving higher fault coverage, and AI-assisted fault diagnosis, employing AI for fault diagnosis, pinpointing the root cause of failure for more efficiency. The future of logic circuit testing. Continued research is focused on developing more efficient and accurate fault simulation and test vector generation techniques for increasingly complex circuits.